Hi, my name is Rob Meaney. I'm Director of Engineering at Glofox in Ireland, and today I'm going to talk to you about testing is not the goal. So who's the smug kid in the right, I hear you ask? Well, that's my son Adam, and for a 24-hour period a couple of years ago, while we were in England visiting Legoland, he was the richest person in our family. Why? Well, Visa had a European-wide service outage. That meant we couldn't withdraw any cash. So Adam, with a sum total of £45 in his little Velcro wallet, was now our chief holiday financier. And for a moment, I panicked as I tried to figure out how we were going to pay for food, transport, and accommodation in a foreign country without access to our bank accounts. It was a situation that made me feel acutely aware of how dependent we've become on software systems and of how utterly vulnerable and helpless it can make us feel when they don't work. But it also made me think about the teams of engineers that were scrambling in the background to resolve the issue. I've been there myself. I could almost feel the stress, the pressure, and the subsequent shame that they'd have to endure. Within minutes, the outage was plastered all across social media, and within hours, it was all over mainstream news. I could almost hear the blame-laden questions being asked by senior management. How could this happen? Why didn't you test this? So what I've learned is that without adequately managing the complexity of our systems, they will inevitably fail with horrible consequences. And there are real costs to software failure, both financial and human, for both our users and the people building and operating our software systems. So the question is, how can we deliver value to our customers quickly, reliably, and sustainably when we're working in this increasingly complex world where everything is connected, change is continuous, and failure can be catastrophic? So even though Glofox is a relatively small company, we find ourselves working with a hugely complex distributed system with dozens of interconnected services that are constantly changing and evolving, deployed to a cloud platform, in our case AWS, that we can't rely upon. All cloud providers have outages, and integrating against third-party services whose API and responsiveness can change at a moment's notice. So in contrast, when I started in the software industry about 15 years ago, we had these all-encompassing big bang releases of a monolith. And when it went wrong, it went very, very wrong, and everybody knew. Whereas now we have a constant stream of releases with lots of little failures that may or may not even be noticed. So we have to assume our systems are in a constant state of partial failure. So this scary new world presents a whole new set of challenges and risks, and consequently requires an entirely new approach to deal with these risks. So we need to unlearn our old ideas about development, testing, and operations, and embrace a new reality in this complex new world. The truth is, our job is no longer finished when we deploy to production. It's just beginning. This is where we really start to learn about our systems and how they actually behave, as opposed to how we imagine they behave. Tests are not reality. They are simply our best guess. We need to accept that we can't anticipate and test all the ways in which the system could fail. They're infinite. No amount of testing can tell us what will happen in production. So we need to shift from imagining how our systems will behave to understanding how they actually behave. So we need to accept that failure is inevitable in these complex distributed systems. And in the face of this reality, we need to rebalance our efforts, not just on prevention and detection of problems, as has been the tradition, but on mitigation and recovery, so that our teams can move quickly and safely with justifiable confidence. We need to create resilient, anti-fragile systems. So today's high-performance teams have learned to deliberately design testability and operability into their systems from the very, very start. I've learned that managing risk effectively is the key to delivering value to our customers quickly, reliably, and sustainably. A focus on testability allows us to manage the risks that we can imagine, while a focus on operability allows us to deal with the realities we cannot. So today I'm going to talk you through the journey that has led me to these conclusions and explore the patterns that have allowed our teams to achieve both speed and stability at scale over the years. So I'll share 3 career-defining experiences and the associated insights related to, firstly, testability, operability, and then observability, and how they've allowed our teams not just survive, but thrive in this complex new world. So my journey begins as a software automation engineer, I guess, about 7 or 8 years ago. And we're going to start with testability. And forgive me for the shameless plug here for the book I co-authored with Ash Winter. So I had just joined a US hardware company that was building out a brand new software engineering department in Cork, Ireland, where I live. As part of our onboarding, the whole engineering department was asked to perform regression testing for a forthcoming release. So after 7 weeks, yes, 7 weeks of torturous regression testing by the entire engineering department, the release limped out the door. And soon after, one of the developers who was acting as architect in the Cork office approached me and asked me one simple but very profound question. How can we make this software easier to test? So we explored the testing challenges we had faced, and I came up with a model I now call the CODS testability model. So CODS is a mnemonic, and the letters are intended to remind us of 4 important testability attributes to consider when designing or architecting software systems. So C is for controllability, the ability to identify and control the variables that influence system behavior in order to visit each important state. O is for observability, the ability to observe and understand everything important that's happening in the system. D is for decomposability, the ability to decompose the system into independently testable components. And S is for simplicity, the ability to easily understand the system. So we implemented our design based on the CODS model, and after overcoming a really steep initial learning curve, we began to see truly remarkable results. So let me explore the impact that testability had on our productivity. So in my experience, a well-tested system is both checked and explored. I tip of the cap here to Elizabeth Hendrickson's excellent book, Explore It. So we check to confirm our existing beliefs about the software system and its behavior, the knowns. Does the software do the things we developed it to do? And we explore to uncover unexpected risks, the unknowns, the problems we couldn't or didn't anticipate and only become obvious through interacting with the software. And by focusing on testability, we improve both the automatability of the software, i.e. the ability to automate checks from a coding perspective to confirm expected behavior of the software, and the explorability of the software, that is the ability to uncover the unexpected and to reveal new information that we didn't already know. So what's explorability? So explorability is the ease with which we can run fast, cheap, safe-to-fail experiments. Exploration is almost the complete opposite of automation. Exploration is the most effective means of managing situations of great uncertainty or complexity. There's always uncertainty in new software systems. It's a very human process centered on learning that requires people to use their intuition, skills, and experience to refine their mental models of a system. By making the software more explorable, it accelerates the speed at which we can gain a deeper understanding of how the system behaves and why. So John Boyd's OODA loop is a great model for understanding how we explore. We perform a series of small, fast, safe-to-fail experiments to gain situational awareness in order to best adapt to situations of uncertainty or complexity. The faster we can iterate through the loop, observe, orientate, or sense make, decide, and act, the faster we can learn and adapt in complex and uncertain situations. These ideas can be applied to things like finding product market fit, testing complex distributed systems, and even debugging production issues. So going back to my story, before focusing on testability, we were in the bottom left-hand quadrant of this diagram. That is, we had a poor understanding of both the expected and unexpected behavior of our software. We spent most of our time either manually checking for expected behavior or fixing flaky test automation. We spent almost no time exploring for unexpected risks, which meant that lots of problems were going undetected or were detected very late. By focusing on testability, our automation coverage became far broader, deeper, and more robust, checking thousands of attributes in seconds. It proved excellent at detecting bugs and provided almost immediate feedback on every change. This foundation freed our testers from having to check expected behavior so they could now explore for unknowns, unexpected behavior, and risks. We began doing valuable testing that we'd never had the time to do before. We began to do deep exploratory performance, resilience, and security testing, and finding new and interesting types of bugs. With both great automation and exploration, the speed, depth, and breadth of our testing was incomparable to before. So this balance between exploration and automation worked perfectly, as automation failures drove action. They provided reliable behavioral change detection, and automation failures invited exploration. And our exploration drove understanding, both of the expected and unexpected behaviors. So this combination of fast, reliable automation and deep skilled exploration allowed us to minimize the time and effort in achieving shippable quality for each new change, or in other words, minimize the transaction cost of getting changes to production. So what did this focus and testability achieve? Well, over the following 12 months, the transformation was truly remarkable. The design approach was adopted by teams in both the US and the Irish offices. The speed of delivery and quality of the product improved dramatically. Releases went from 7 weeks of testing to 2 to 3 days of exploratory testing. And the teams were able to work at a sustainable pace and were proud of the work they were doing. And after this experience, I had a profound realization. Significant quality improvements weren't driven by testing. They were driven by building relationships and influencing the right people at the right time to build quality in. So this brings us to the operability leg of my journey. So I started working with an early stage startup of about 20 people in total, maybe 6 software engineers. We were a business-to-business SaaS-based company providing real-time online fraud detection. And the product was beginning to gain real traction with some of the biggest retailers in the world. So it was a new context for me with a completely new set of challenges. It was the first time I had worked on a SaaS product, but I quickly learned that because our service was on our customer's cart page, it was critical that our platform had to be available, responsive, and scalable to fluctuating customer needs. But building out robust automation and doing deep exploratory testing was only a starting point in this context. This taught me almost nothing about the availability, responsiveness, and scalability of the system in production. I soon found out that no matter how much testing I did pre-production, we still experienced problems when we deployed changes. I realized that we were no longer simply testing code, but testing complex systems comprised of real users, real data on real infrastructure. We simply couldn't recreate the variety, volume, or complexity of production-type traffic in our test environments. So the reality is with these complex distributed systems that if you're not testing in production, then it's your customers that are actually testing in production for you. So we needed to test where our greatest risk lived, which was production. So I reframed the CODS model that I spoke about earlier to focus on operability, to make it safe to deploy and test in production. And we did this by, firstly, controlling risk exposure. We began doing blue-green deploys, which allowed us to revert the deployment quickly and easily if we detected an issue with minimal impact to our customers. Observing system behavior. We added instrumentation to visualize our critical customer pain points, the error rate, response time, and the whole team monitored the system during releases. We decomposed deployments so that each deployment was limited to a single change set, which meant we could quickly isolate the source of a problem if an issue was released. And simplifying the deployment process. We could deploy a rollback with a single click of a button and created runbooks to help debug issues in production. This approach hugely accelerated the rate at which we could ship, while also reducing the negative impact caused by any issues on our customers. It opened my eyes to the power of deliberately testing in production and managing risk with operability. So here are some of the examples of the techniques we used in that company when designing for operability, using that CODS model to manage risk. So we control risk exposure using techniques like blue-green deploys, feature toggles, canary releases, and A/B testing. We observe system behavior using things like alerts, synthetic tests, logging, monitoring, and tracing. We decompose our deploys into single change sets per deploy, and we simplified our deploys so that we could deploy with a single click of a button, or rollback with a single click. And we had automatic rollback on error rate spikes as well. So another lesson I've learned is that when it comes to operability, you have to go beyond just testing the production code. You need to test the infrastructure and the tooling that supports operability. You need to test that your infrastructure and tooling work when you need them most, when things go wrong. So this brings us to the third and final leg of my journey, observability. I think the picture here perfectly captures how many companies deal with observability. So my last role in the last company I worked with was quality engineering manager with a company called Popular. So I worked with all our engineering teams, enabling them to identify and achieve their quality goals. So as I said, I worked kind of like a coach. So having seen the power of designing systems with a focus on testability and operability, I shifted my focus from testing to coaching teams to build quality into the product from the start. So as a coach, one pattern I identified is that of the 4 CODS operability attributes, observability is the first and most important thing that teams need to focus on when I begin working with them. Why? Well, observability allows the team to get a true understanding of how healthy their system currently is, how their system actually behaves as opposed to how they imagine it behaves. It allows them to get an understanding for the reality of what their users are experiencing. And lastly, it allows them to identify where they need to focus their quality efforts. So when working with teams, I start with very simple questions. How would you know if your system wasn't healthy? How would you know if your users were having a bad experience? In the event there was a problem, how would you isolate the cause? So this simple technique gets teams thinking about what aspects or attributes of their system are really important. It gets them identifying and adding important health indicators and using things like service level objectives. It helps them gain an understanding for what normal system behavior looks like so that they can identify abnormal system behavior. So in Glofox, my current company, we've begun looking at these basic health indicators holistically. So starting at the infra level, moving up through our services, our product, our customers, and ultimately our business. And we've introduced Honeycomb, and it's really gaining traction across our teams. So going back to observability, this may seem familiar. A well-observed system is both checked and explored. We check the system for known failure scenarios, or knowns. Symptoms we know are indicative of customer pain. And we explore the system for unexpected behavior, unknowns. We explore the data looking for unusual patterns. So we check for symptoms or indicators of customer pain. There's a finite number of indicators. And in the case of our customers are experiencing pain, we explore to identify the cause or the source of the pain. For example, when we go to the doctor, we don't list all possible causes, we list their symptoms. So by focusing on observability, we improved both the monitorability, which is the ability to detect customer pain, and the explorability, our ability to understand system behavior or cause of the pain of our production systems. So previously in Populo, we had low observability. We wasted most of our time in a sea of noisy, unreliable alerts and creating hundreds of dashboards for every potential cause we could think of. But more often than not, it was our customers that were reporting issues, not the alerts. And even when they did alert for genuine system outages, they only told us we had a problem, and it was very difficult to isolate the cause of the issue. The results of focusing on observability were that the teams had a smaller set of better, more reliable alerts that were focused on identifying the symptoms of customer pain, not monitoring for cause. And when they alerted, we knew we needed to act immediately. The explorability allowed the teams to get a deeper understanding of system behavior and quickly slice and dice the data to get to the cause when there were outages. We could ask questions of the system without needing a release. These teams started curiously exploring their production data, identifying interesting anomalies and sometimes long-standing undetected bugs. In many cases, these teams were now able to quickly detect system outages and correct problems before customers were either impacted or aware of the issue. So great monitoring drove action, allowing us to quickly detect production issues, while great explorability allowed us to understand the cause of the problem through skilled debugging. And this combination minimized the effort in detecting and resolving production issues. So about the same time that I began working with our teams on observability, we adopted the metrics from Accelerate. For those of you who don't know it, it's a fabulous book by Nicole Forsgren. So what I noticed was there was an interesting relationship between the Accelerate metrics and how testable and operable our systems were. Teams with low testability and operability were low performers. Their testing was slow and ineffective. And when they had production issues, the impact was huge on the team, the business, and our customers. By improving testability, teams made more informed decisions on the risks they could imagine or anticipate, reducing the likelihood of introducing a failure, and allowing them to move quickly with confidence. While by improving operability, it allowed teams to deal with the realities they didn't or couldn't anticipate. Remember, failure is inevitable, so it allowed them to reduce the impact of failure when it did occur. So the combination of high testability and operability provided a hugely powerful mechanism for managing complexity and the associated risk. So again, testability reduces the likelihood of failure, while operability reduces the impact of failure, allowing teams to produce quality software at breakneck speeds. So focusing on testability drove throughput in terms of the Accelerate metrics. It reduced lead time for change and increased deployment frequency, which ultimately minimized the time and effort to ship changes to production. Operability, on the other hand, drove stability in production in terms of reducing change failure rate and mean time to recover, which ultimately minimized the time and effort our teams spent dealing with quality problems in production. These combined allowed us to achieve optimized flow by accelerating the delivery of value and minimizing the cost of poor quality. So, what have I learned from these experiences? When we deliberately design and evolve our systems to make them easier to build, test, and operate, we can easily automate the predictable, boring stuff. And because computers are faster and more reliable at doing predictable, repeatable, mundane tasks, the painful stuff that people hate doing, and we can easily explore the unexpected, interesting stuff because people are creative and curious problem solvers. We enjoy exploring uncertainty and complexity because that's how we learn new and interesting things. So we can concentrate ultimately our efforts on building software people love. So how can we make this happen? That's the next obvious question. Okay, so we need to cultivate an environment where teams, and when I say teams, I mean everybody involved from concept to customer, are empowered to work together to seek problems, solve problems, and share their lessons. Because if there's one thing that I've learned in the last 8 years or so of working in this complex new world, it's that when you optimize for a great engineering experience, you get happy, high-performing teams and a successful business as a second-order effect. Thank you very much.